This is part 3 of the Unbeatable Noughts and Crosses aka Tic Tac Toe AI series. In part 1 and part 2, we have built the game with AI already. If you haven't watched them yet, be sure to watch them first. You can find the link to those videos in the description below. In this last video of the series, I want to show you how I generate the game board state we use for the AI. Let's get started. Hi everyone, this is Benson. In the previous video I said I'll explain how I generated state strings we use for the AI. We have winning states, okay, some draw states, and some losing states. After this video, you should have everything you need to recreate the game. I'll also upload the finished Excel file so you guys can download it and try it yourself. Let's take a look at the game board. It has 9 positions. Each position may have 3 possible values. It can be not, across, or empty. That means there are 3 to the 9th possible states in this game. What we want is to generate 19,683 unique state strings that cover all possible states. Let me use this simple case to illustrate the idea. The first position can be a not, across, or empty. So if the game board has only one position, there are 3 states only. If it has 2 positions, each of these scenarios may have 3 choices for position 2. Thus, there are 3 times 3 equals 9 states. If you know a little bit about SQL, I bet you can immediately see that this is a full outer join. This is exactly the technique we will use to generate these state strings. If we set up a table which has 3 values, -1, 0, and 1, and do a full outer join to itself by 8 times, we'll have what we need. Excel does not support SQL, but it has Power Query. So let me show you how. So first, let us refresh our memory what a state string is. Take this one as an example. Okay, a state string has 9 characters because there are 9 positions in the game board. Each character represents a choice of a particular position. The first character represents position A1. The second character represents B1. The third represents C1, and so on. The first thing to do is to set up a table. So I create a new workbook first. Set up a table. It has a state column, and it should have 3 rows: -1, 0, and 1. Later on, you will see why I choose to use numbers to represent noughts and crosses instead of using X and O. We also need the join column since we want to give it a key to join when we do a full outer join. So set up this column, set it to 1 for all 3 rows so that each row will match every row. Then select the table, go to data, get data from other source, from table. Okay, my table has headers, yes. Click OK. This creates a table query. So click close and load. We now have our first query. What we'll do next is to use this merge function here. Data combine query merge to join the query itself. Alright, this is the tool we will use to join the table. So the first table is already selected, table 1. We want it to join itself, so I select the same table at the bottom. Notice that this OK button is disabled. It's because we haven't selected the join key. So select the join column on both table. Now it knows the join key. Now you see that the OK button is enabled. Click OK. Okay, now we have the joint result. Make sure you click this icon to expand the rows. Okay. Now you can see all 9 rows. We have 9 rows because the first table has 3 records, and we join the table by itself. So 3 times 3 is 9. Okay. We have to keep doing this because we only have 9 rows so far. You can do this by clicking this merge query. Now you can merge this with the original table. This would be 9 times 3 records. However, it will be faster if we join this 9 rows table to itself again. So it gives us 81 records. Again, I need to select this join key. Click OK. Click this icon to expand the columns, to expand the rows. Now we have 81 rows. Do the same operation again. Merge queries. Join, merge 1. So this time we have 81 records times 81 records. Okay. Select the join key. Click OK. Click this icon to expand the rows. Now 81 times 81 is 3 to the power of 8. So we need to do this one more time, but this time we only need to join it with the original table, which only has 3 records, so that we have 3 to the power of 9th records. Okay, select the join key, click OK, expand. At this point we have all the rows we need, so we can remove these join columns. I'm also pressing Ctrl to multiple select these columns. Okay, select all the join columns. Join. And then right click, remove columns. Okay, click close and load. You see that we have 19,684 rows, including the header. That means we have 19,683 rows. Okay, what we need to do now is to copy this whole table. Create a new worksheet and paste the value. I use paste as values, so I can work on this data. I will also rename this header to the corresponding position. So A1, B1, C1, A2, B2, C2, A3, B3, and C3. Okay, now I want to convert this into the state string we use in the game. State string. So basically what I need to do is just to substitute -1 to O. 0 represents empty, so I will replace it with a dot, and then replace 1 with a X. Okay, so let me write the formula here. I should concatenate the whole range first. So this whole range, concatenate it to a string, and then I use substitute. First, let's deal with -1. Substitute it with O. Then I substitute the result string again. This time I will handle 1 and replace it with X. Finally, do it one more time. Replace the 0 with a dot. Okay. Now I copy this formula. Alright. So now we have all possible states on the game board. However, many of the states do not comply with the rule of the game. For example, the first row here, it has all noughts at 9 positions. That is an invalid state because we cannot have all noughts in all 9 positions. So what I want to do now is to write some formulas to filter out the states we need. The first one is valid state after x turn, valid state after x, and then we need to see the valid states after O's turn, and then we'll detect winning pattern, losing pattern, and then valid win state after x turn, valid lose state after O turn, and then the draw state. Okay, let's close this query. Okay, now let's work on the first one. Since we assume the human player goes first, that means every time X has finished a move, the number of noughts and crosses should be the same. That is easy. We just need to sum all the position values here. If it equals 0, that means we have an equal number of noughts and crosses. Okay, so just do a sum. Okay, if it is true, if it is 0, that means it is a valid state after x turn. Okay, so clearly this one should be false. Okay, let's copy all this formula down. Okay, we have some true state here. Okay, 2 noughts, 3 noughts, 3 crosses, so is a valid state after x turn. Okay, great. Now I also want to set up an auto filter for this, so that I can easily check the states. Column R, data filter. Okay, now let's filter all the true states. Okay, all these states have an equal number of noughts and crosses. Okay, what about the false ones? Okay, these are all false cases. Great. Okay, now the next one, valid state after O. The formula is basically the same. except that we should have one more knot than cross. Since knot is -1, that means the total should be -1 if we just have one knot more than cross. So again, sum the whole row. If it is equal, if it equals -1, that's a true. Okay, let's take a look at the true cases. Okay, this one, it has 5 knots and 4 crosses. Okay, so this is a true case. This means it is a valid state after the human player knot's turn. Okay, because it has one more knot. It has one more knot than the number of crosses. Okay, this looks fine. Okay, next one is the winning pattern. What I mean here is the winning pattern for AI. Okay, it means that there are 3 crosses in a diagonal, horizontal, or vertical row. 3 rows plus 3 columns plus 2 diagonal equals 8 conditions. So we should have OR condition. So I should have 8 conditions. The first one, I just sum these 3 cells, which represent A1, B1, and C1 on the game board. If they're equal, if the sum equals 3, that means we have 3 crosses here, right? And then we handle the second row. If it equals 3, we also have a winning state. Now the third row. Okay, so we have handled all the rows. Let's take care of the columns. The first column should be the sum of A1, A2, and A3. This is the left column. Now the middle column is B1, B2, and B3. And the column on the right, C1, position C2, and position C3. And then the diagonal, so it should be the top left corner, the middle, the center position B2, and then the bottom right corner. Okay, this is diagonal, the from right to left. So C1, B2, and then A3. Oh, I missed the equal 3 here. So equal 3 equals 3. Now, okay, let me check this formula once again. Let's copy this formula down. Okay, again, I check the true case first. Okay, this one, 3 knots, 3 knots, 3 knots at the end. Okay, looks fine to me. Now we just do the same for losing pattern. The only thing is that the sum should be -3 because we are detecting 3 knots instead of 3 crosses. So I just use the same formula and change all the total value to -3. Here we go. Okay, let's take a look at the true cases. This one all knots, so it must be a losing state, although it is not a valid state. Okay. Finally, we work on the 3 states we really need for our AI. Valid win state after X turn, valid lose case after O's turn, and draw state. Valid win state after X means after X has finished his turn, the game board contains a winning pattern for X and it does not contain a losing pattern. Okay, let me resize this column so it's easier to see. Oh, I have a empty column here. Just delete this column. So the formula is easy, and first it must be a valid state after X, so and K2. The second condition, it must have a winning pattern, okay. And it should not contain a losing pattern, so not losing pattern. Right. Now for this one, it is similar. So equal and lose state, that means it should be a valid state after O. And it is not a, it does, a winning pattern does not exist. So not winning pattern, and a losing pattern must exist. Right. At the draw state, the whole game board should be filled, and Not goes first. So the last turn should be Not's turn. So it has to be a valid state after Not. At that state, there should be no zeros, no winning pattern, and no losing pattern. Okay, again I use a AND. So it should be a valid state after Not's turn. And then we count the number of zeros. We count the criteria is 0, and the numbers should be 0 because all positions have been filled. And then there should be no winning state, so not winning pattern and not losing pattern. This is how we detect a draw state. Now we're done. To get the win state, just filter this column, valid win state after X turn. Filter it by true. Now these are all the states for win state. So we can just copy and paste all this game state strings to the workbook we did earlier. Same for the lose state and draw states. Alright, this is how we generate the game state strings for our Unbeatable Tic Tac Toe AI. I will upload this finished Excel file so that you can download it if you want to. I will add a link to the description box below. Remember that I use AlchemyJ Excel library for the regular expression pattern matching. So go download AlchemyJ Excel library at alchemyj.io if you haven't done so. This is the end of the 3-part series. If you enjoyed this video, please like, share, comment, and subscribe before you go. Take care, and I hope to see you in the next video soon. Bye.